Hello everyone, welcome to MCP Quest. This is Ross. Today we're going to talk about the MCP transports. So here is the official webpage about transports. So here we can see the MCP server mainly supports two methods. One is STDIO transport and the other is streamable HTTP. Today we're going to use our old friend, the BOM MCP DB server to explain how they work. Okay, let's get back to our code. So previously, our BOM DB MCP only support one method, which is STDIO. But now I just modify the code to support multiple transport. You can see apart from STDIO, it also supports HTTP and SSE. So if you are interested in it, and just clone the GitHub and take a look. So everything is in this folder. I just prepared 3 TypeScript files. Each one just implement one transport method. So to make it work, it's very easy. You can simply just pass some parameters that should work. So if you take a look at this, I prepared 3 scripts. One is a start STDIO, that's O1, and then SSE, and then start HTTP. Okay, now let's take a look at how the MCP transport works in Postman. So in previous videos, we only use STDIO, this transport. In Postman, you only need to specify your executable and the path, and you click connect, it works. So here you see, I don't need to run anything in my BOM DB MCP repo. I don't need to run anything in a terminal or at any places. So Postman, this MCP client itself should be enough. And I can connect, I can call different tools. But there's actually another way to run MCP in your Postman, which is HTTP. So let's disconnect it. If I click this one, you'll see another method, HTTP, and let's duplicate this endpoint, rename it to HTTP. This method, you need to run something in your terminal. You need to start a server to run it, right? And so we can use this command, starts HTTP. You just do npm run start HTTP. It starts a server. The endpoint is this, and you need to post a request to this endpoint. So I copy this one, and then come back to Postman. I just copy this endpoint, paste it, and I save it. Okay, click connect. It works as well. So you see, it just works in the same way. You can't tell just from this UI. You can see everything is the same. That's STDIO and this is HTTP. So actually you can start this to run simultaneously. I can still connect using STDIO, but meanwhile I'm also using HTTP. So they just work in the same way. And if we do something like this, from Postman you can see this history. So this is the request that we sent, and this is the response that we received from the server. So if I run a query, let's say just select star from employees, I don't know, maybe do 5 records. I click run, you see. So this one is the request I sent to the MCP server via the HTTP transport, and this is the response that I received from the server. So here you see an interesting format. This one, you see that it follows the same pattern. This connection, we see that's method, parameters, JSON, RPC, ID, and this one is the same. You see, yeah, the only difference is this ID is 5. But this ID now is 6. So this format is called JSON RPC. So let's first take a look at how the JSON RPC is used in MCP and why it's useful. JSON RPC is a protocol which stands for Remote Procedure Call, but it's over JSON format. But what it is? Well, first of all, it is a lightweight protocol. So which means the transport efficiency is very high. And then both request and response, they just use very common JSON format. The third one and the most important one is that it's transport agnostic. At the application level, you don't need to worry about is TCP or HTTP, just work in the same way. JSON RPC is often used in 3 cases. First, it is used as a request called from client in JSON RPC format to call the remote function on the server. And then once the server receives the request, it can also send the response in JSON RPC format back to the client. In the third case, it is used as a notification. You just send a request to the server without expecting any response back. It is important to be aware that both request and response, they require an ID, and this ID must be the same such that we know the response actually matches the request. However, in the notification format, this JSON RPC does not need any ID because we don't expect any response for this notification. Here is an example of JSON RPC as a request. We want to list all the tools on the MCP server, so we send this request. This JSON RPC request must have the following fields. You need to customize the ID. It could be any number which identify this request, and the response will automatically contain the same ID. The parameters is most important. Is something you must customize, which often contains the function name, the remote function name, and the remote function arguments. Once the MCP server receives their request, it's going to generate a response also in JSON RPC format. If it is successful, it could be something like this. It also contains the JSON RPC, this 2.0 is fixed, and also the ID, and this ID is the same as your request ID. And here is the body, and the body is the result. It contains all the tools as you requested. If it failed, it's still going to send you a response with the same ID number and also with an error code, which is a minus number. The client and server is just using JSON RPC, this protocol, to talk to each other. Whether we are using HTTP, TCP, or WebSocket, they just work in the same way, and it's very flexible and very high efficient. Okay, now we understand what a JSON RPC is, and Postman is also using a JSON RPC to communicate, send requests, and receive response. However, I noticed that the Postman, you can't see the network traffic, right? So we send HTTP requests, but it does not look like the inspector of the browser. You can't see the network traffic. Apart from Postman, here I recommend another very powerful MCP client tool called MCP Inspector, and this one is also mentioned on Anthropic's webpage. To use it, it's very simple. You can just call this npx command, but what I did, I just cloned the GitHub repository, and now I can simply do node build cri.js, and it's gonna open it in my browser. Yeah, here it is. I already put some command and also the executable paths at here. So this is STDIO. So you can also use Streamable HTTP and also has SSE. So you can click this connect button. See, there's resources and templates and tools, prompts, everything is here. And because it's a web app, you can use browser's inspector to view the network traffic, which is pretty cool. And let's try it again. If I disconnect it and connect again, you see the network traffic. And here we can view the payload. Yeah, this payload is a JSON RPC format. You can do the same thing yourself if you want. Okay, now let's come back to our terminal. We want to test how the STDIO works without using any MCP client. We can actually do it by ourselves. But first, let's just check how the STDIO works. Now I'm gonna show you how it works from a very simple Python script. So we can create a file, and let's say temp and test STDIO. So we just go through this file. What we want to do is just we can create a loop. Say while. So let's see greetings. Okay, it just automatically complete it. So it's just like this. So it takes some input from user and then just directly print. It's just a endless loop. Right? If I run this file, I enter greeting, I say hello, and they just say hello. Yeah, just an endless loop. This is STD in and this is STD out. By using this way, you can communicate with the application. As you provide input, it gives you output. Well, MCP STDIO, it works in the same way. You can simply start a process by doing npm run start STDIO. So the process running similar to the test STDIO.py is ended this loop. So let's do something interesting. Let's come back to the inspector. It's STDIO protocol, it's bound, it's passed. Okay, now let's connect it. Okay, let's first try the tools. Let's list the tools. Okay, so you see it lists all the tools, and from here you can see it just sends a JSON RPC request. So we can copy this one and paste it to our terminal. Okay, see the terminal, it works in the same way. You pass this a JSON RPC body, it gives you the response. Let's see the ID equals to 1. This ID also is 1. The response matches the request. Now let's just run the tool. Let's first run the connection. Okay, connection requires an function argument. It must be one of connect, disconnect, and status. Run it, it's connected. So we copy the same JSON RPC body. Now you see the ID is 2. Put it here. Okay, status is connected. Let's try another one. Let's run a query. The SQL could be anything from employee and name it 2. So I run it. So you see it just returns 2 record. Still the same. Now the ID is 3 for the JSON RPC body. I copy it and come here. Yeah, it just returns all the records. I'll just be aware. So to make it work, you need to set some environment variables, right? I already prepared it. So you need to provide a DB host, DB port, and user password, this sort of thing. Otherwise, you can't connect. So similar to the postman. It's worth noting, STDIO is convenient to use, but tricky to debug. As we already see that STDIO, it always starts new process from any MCP client. So you can't just debug this one in your VS Code because it's a separate process. And also, you can't use the console.log to add debug messages. So if we do something like console.log on this sort of debugging messages, we already mentioned this before, it's gonna pollute your STD in and out communications. So for instance, we start this one and we just paste a JSON request. So you see, it prints out 2 messages. First one is debugging message, and only second one is JSON RPC response. And this will confuse your MCP client. So this way of debugging is not recommended. But how to overcome this sort of thing and how can we debug? We have to use the server side transport, right? We can use Streamable, HTTP, or SSE. It can help you to debug. Now let's see how it works. Okay, now let's take a look at another transport type. This transport type is an streamable HTTP. Unlike the STDIO, streamable HTTP transport requires the server to initialize the process. So we have to start the server first. So here in our bound DB MCP repository, we can use start HTTP. This script, we run npm start HTTP. Okay, now the server is running, and that's the endpoint. You can connect with it. Yeah, so everything is same. You can see the tools, you can do the connect. We can do the same thing here in our terminal. And let's try to see how it works. Because it's a web server, it's just like REST API. You can use many terminal tools like code to send a request. The first request we send must be an initialized request. We use this request to acquire the session ID. Here's an example. So we call a code command. So we send the post request body to this endpoint. So that's the request body. Method is initialized. Just be aware of this header. So it must accept 2 contents, right? One is JSON and the other is event stream used for SSE. So this is required by the MCP protocol. You must do this, otherwise it's not gonna work, okay? So let's just start it. Yeah, so that's the response. So you see in the response header, we see an MCP session ID, and you need to use this session ID for all the follow-up requests. So on the server, we can also see the session initialized using this one, so that's the session ID. Okay. So just to make it more handy, we save this one to an environment variable. I do export session ID equals to this. Yeah. And now we can send a follow-up request and call this code command. So you see the method is choose list. I must put the session ID into the MCP session ID header. Yeah. So the response just tell me all the tools available. Now let's execute some tool. Let's first do the connection. This time ID should be 3. ID 3, action connect, but still we need to use MCP session ID. Okay, it's connected. Now we can execute some queries. This time ID is 4, and we are going to execute this SQL query. Yeah, so from terminal, you can also do the streamable HTTP. You don't need to use MCP client, so it just works in the same way. And the advantage of using streamable HTTP is that because it's running on a server, you can debug it. You can put whatever console.log, and you can also use VS Code debugger. Yeah, let's just see how the debugging works with streamable HTTP. So we can put a debugging command here. So this time we need to use TS node because the bound does not work at here. We can just use TS node here because it's ESM package. So that should be enough. TS node ESM SRC, okay. And we can run this npm script from here. Let's see, we just do here. That's Node.js. Let's debug HTTP, yeah, this command. And we can add some breakpoints somewhere here. We just run it. Yeah, I think we need to stop this one first. Let's run it. Okay. And now let's just come back to MCP inspector and list all the tools. Now, if I execute this connections command, the debugger should stop at here. I do the connect, I run the tools, you see it's running, it's here. Yeah, it stopped at here. And because this handle connection is the first tool, which is a connect tool. Yeah, so you just can go with it. Yeah, so it returns some result. It's an error, but that's fine. So now you know you can use debugger at here. It's gonna be very convenient. You can also put all your console log at here. So that's the advantage of the HTTP transport. You may notice from the MCP inspector, there's another transport type called SSE. So this one is gonna retire soon according to MCP's official documentation, right? But for the backward compatibility, it's still good that we can understand it. So because there are many MCP servers, existing servers still using the SSE, this protocol. Let's see how it works. First of all, same as before, let's start a server. npm run start SSE. Yeah, it starts SSE server. And at here, we can just connect it. Right? It works in the same way. You can list all the tools and you can just run it. Now let's see how to do it by yourself from the terminal, because only if you do this one on the terminal, you understand how it works. Okay, to demonstrate how the SSE transport type works, we need to start two terminals side by side to explain what's going on. SSE is different from HTTP transport in terms of the connection. So SSE requires maintenance of a constant, uninterrupted connection. What do I mean by that? So whenever a client wants to initialize a connection to the SSE server, and you need to do something like this. I call it call command. So let's do endpoint. The -n just means the no buffer, right? So if any data is available, you can immediately see. So if I start this connection, you see, and the client can immediately get a session ID here, and you need to use the session ID for all the follow-up request. This is similar to the HTTP protocol. Okay, so first of all, same as before, let's save it into an environment variable. Now we can call the MCP commands. So let's first list all the available tools. We can still send the code command like this. So the ID equals to 1 is first calling. That's tools and this. See, it lists all my tools. And then I can call the connection. This one. Yeah, and just copy paste. So that's the connect method. Yeah, it's connected. Now I can execute the query. So that's my ID 3. Okay, now we see the SSE and the HTTP. They look quite similar, right? So they're both running on the server and you send a code request and get response. But what are their difference? Well, the key difference between these two is how the response is received. In HTTP transport, you send a request and get a response immediately, right? Just from the same connection. However, with SSE, the request and response not happen on the same connection. You send a request using this code request, but you receive the response from another separate continuous running SSE connection. So you always receive response from this connection, no matter where you send a request. So you must make sure this connection is constantly running without being interrupted at all times. So that's the life cycle. If this one discontinued or is stopped, then now this one gonna work. So that's the key difference. Okay, now let's wrap up today's discussion by compare these three MCP transport types. STDIO is run by the MCP client locally. It does not require running on the server, but it lacks support for VS Code debugging, and it requires a live connection. It can't be interrupted. HTTP runs on a remote MCP server, and it supports VS Code debugging, and it does not require a live, uninterrupted connection. So this is very good. SSE is also run on a remote server, and it also supports VS Code debugging. However, it also requires a live connection which can't be interrupted. So we should try our best just to use HTTP. So this transport type is the best. The SSE, the Anthropic said is gonna retire this one in the future. Thank you very much for watching. If you enjoyed this video, don't forget to give it a thumbs up, subscribe to the channel, and hit the notification bell so you don't miss future updates. Okay, see you next time.